The factor theorem states if c is a zero of a polynomial function, then x minus c is a factor. In these problems, we'll use our calculator to find the real zeros of a polynomial, and then use a factor theorem to factor the polynomial. We'll take a look at two examples in this video. The first example is a function of x to the third plus 8x squared plus 4x minus 48. The directions say factor the polynomial and find the zeros. First, we're going to find the zeros in the calculator. First, we'll enter the function. In the graphing screen, we have x to the third plus 8x squared plus 4x minus 48. We'll use a standard window, zoom, number 6. Now remember with the definition of a zero is an x-intercept. So the real zeros are here, here, and over there. So we have 3 real zeros. To find the zeros, we'll press second, calculate, and choose command number 2. I'm going to show you how to find the zero on the left. Now first, we need to give the calculator a left bound. The left bound is down below the x-axis since the function is increasing. So I'll move my cursor right here and press enter. Alright, next we'll find the right bound, which will be above the x-axis. So move your cursor anywhere up above. Right there will be fine. And press enter. And then I'm going to move the cursor down near the x-axis for the guess. Press enter one more time. And the calculator says that the zero is at the value of -6. Alright, so there is our first zero. Now we'll find the other two. It appears if the function crosses at whole numbers or integers. So if we count over, it looks like it crosses at -4. Now we could press second, calculate again, and use our zero command to find the other two zeros. Or we can hit the trace button and try to guess what they are. Alright, so we think this is at -4. So I'm going to type in -4 after I press trace. Press enter. And it moves the cursor over to -4. And you see that the y value is 0. This verifies that -4 is a zero of the function. The y value must equal 0 in order for it to be a zero. Alright, so the other one is -4. And then we think that the last zero on the right is at 2. I'm going to press trace again and press the number 2 and enter. And we see the y value is 0. That verifies that 2 is a zero of the function. After you find the zeros, you can use the factor theorem to write the factors. And it's very, very important that we see that the factors always have a minus involved, x minus the zeros. So the first factor is x minus -6. The next factor is x minus -4. And the last factor is x minus 2. These negatives cancel out to be a positive. So we'll change these factors to pluses, and the last one stays as x minus 2. So these are the zeros of this function, and here are the factors. We'll look at another example now. The next problem is g of x equals x cubed minus 6x squared plus 5x. Again, we need to find the zeros and also write down the factors. The first step is to graph the function. Looking at the graph, it crosses the axis 3 times. It appears as if the graph crosses at 0, crosses at 1, and possibly at 5. We can verify that by pressing the trace key and typing in our guesses. I'm going to type in 0 first, press enter, and since y is 0, that verifies that our value of 0 is indeed a 0 of the polynomial. So our first 0 is 0. Next, it looks like the graph crosses the x-axis at 1. I'm going to press trace and number 1 and then enter, and the y value is 0. That again verifies it. And other 0 is 1. And finally, maybe over here at 5 it crosses. Check that out. Press trace, type in 5, press enter, and 5 is indeed a 0. So here are the zeros for a function g of x. Writing down the factors, it is always x minus each number. X minus 0 can be reduced to just x. So we have x times x minus 1 times x minus 5. So we found the zeros of the function and also the factors.